8:40 in Kigali.
A good number to start the webinar. I think before we proceed, I will invite Engineer Pearl Esel. Are you? Okay, Pearl, I can see you.
Okay.
Can you give us the opening prayer? Then we can proceed.
Okay, thank you for the honor. In a moment of reverence, shall we pray? With gratitude in our hearts, O God, we thank you for this opportunity to gather across distances, yet united in one purpose for this webinar on nuclear power plants. We pray that you grant us wisdom, clarity, and unity as we discuss issues that will impact our lives and our environment. We ask for humility to listen, the courage to ask questions, and then the vision to plan for the future that is secure, sustainable, and responsible. May our work today reflect our towards safety and foresight. This we ask through your Son, Jesus Christ. Amen.
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 Thank you, Engineer Pearl, for that prayer. So my name is Engineer Momoni Sule. I'm currently the Vice Chair of the Energy Committee, and also I work with Nuclear Power Ghana as a Manager for Engineering Development. For today's webinar, I'll be your MC/host. So you're all welcome.
Thank you.
For
Thank you.
today's webinar, so we've already done with the opening prayer. We'll have an opening remarks from our chairperson, then from some remarks too from the FAO president. Then we'll zoom into the presentation. After that, we'll have some Q&As. Then we'll sign off with some closing remarks. So not to waste much time, I would like to invite the chairperson, the organizer of this webinar, to give us an opening remark. Engineer Flora.
Thank you, Engineer Mumini. Good afternoon, good evening, friends, colleagues, engineers from all over Africa. It's such a great honor for you to join us today for this webinar on nuclear power plant site selection. My name is Engineer Flora Kamanja. I'm from Kenya. I'm a mechanical and also a nuclear engineer. I work for the power utility company in Kenya called Kenya Electricity Generating Company, and my role is to plan projects, power plant projects for capacity expansion in Kenya. So it's indeed my pleasure to welcome you to this webinar, and I'm happy to see the president of Federation of African Engineering Organization, Engineer Faeo, join us. Welcome, Madam President, and thank you. This was your idea, the Nuclear Energy Committee, and Madam President, I want to assure you that engineers are very, very interested to learn about nuclear energy. So many countries in Africa, actually we only have a nuclear power plant in South Africa, and now Egypt is just about to start constructing. The other countries in Africa, Kenya, Uganda, Ghana, and several others are planning to introduce nuclear power into their program. So the Nuclear Energy Committee, basically our mandate is to contribute to sustainable energy solutions in Africa, nuclear power energy being one of them. We know nuclear power plants don't emit greenhouse gases, and as the world gears towards achieving net zero by 2050, then we see nuclear energy playing a very critical role. So here in Kenya, we are at a nuclear power plant site selection stage, and of course, as the speaker, we'll be talking more about it. So we've realized there's need to really create awareness on nuclear power plant site selection, and especially to us technical people, so that as this technology is introduced in different countries, then we as engineers, we as the professionals, we are able to create awareness and enhance public acceptance also to prepare ourselves to work in these nuclear power plants. Nuclear power plant has a huge workforce. Just a 1,400 nuclear power plant can have about over 2,000 professionals working there. So you see, it will also create a lot of opportunity going forward. But we have the speaker for the day, so I don't want to talk a lot. But now allow me to introduce our president, Engineer Faeo, to give our opening remarks. Then after that, we'll hand over back to the moderator to invite the speaker. Over to you, Madam President.
Thank you very much, Engineer Flora. Good afternoon, everyone. Good evening. Good morning. We hope we do have international guests in the platform today. It really gives me a great honor to see that an idea that I had a conversation with our treasurer and with Flora is really starting to come alive. And we have the most number of attendees in this webinar, Flora. So I would like to really commend you and your team for the good work. There is a high interest in the nuclear space, and I'm really quite impressed with the turnout. So keep up the good work. At the moment, this webinar series is our flagship within the quarter that we have now gone through. You're absolutely correct, Engineer Flora. And in fact, we've had a few OEMs within the nuclear space that have engaged with us that are looking to partner with Faeo, and particularly from a point of view of, number one, raising awareness, demystifying what nuclear is, demystifying the opinions on nuclear. But number two, to assist us with capacity building in preparation for the plans that we have as a continent. And Flora and myself have been engaging with a few OEMs, with a few utilities. I do know that last week she was in Vienna, next week she's going to Korea, and I've been talking with Rosatom. So we are really engaging with those entities that would partner with us as Faeo and assist us in capacity building those engineering professionals who are interested in the nuclear space or who are even playing a role in nuclear. So that is something that is really in the pipeline that is exciting. We are also talking about exchange programs and bursaries in the space of nuclear. So I wanted to inform you of that so that you are also aware that it is not only a space of webinars that we are playing and bringing in experts to share with us the information within the space of nuclear, but we also want to make sure that we excite young engineers who want to participate in the space so that there is sustainability. I would also like to invite you all to Africa Engineering Week 2025, which is in Uganda this year in September. Please look out for information. We are having a call for participation, a call for abstracts. I would like to see the nuclear space featuring really strongly this year. We are creating something different as well this year, currently still under planning, where we want to invite CEOs from the energy and the water sector so we can have a panel discussion on this matter. We will not leave nuclear behind. So please look out for that. And we look forward to seeing you in person at Africa Engineering Week. But for now, we will keep engaging on these platforms. Thank you very much and enjoy the webinar. Over to our MC.
Thank you, Madam President. Thank you, Madam Chair, for the opening remarks. Today's presentation is part of a series of presentations that we have planned for the year. We've already had one last month on nuclear energy basics. So today we'll be having another webinar on the topic nuclear power plant site selection. So site selection is one of the major issues, infrastructure issues that has to be resolved in the nuclear power program. So before I hand over, I would like to briefly introduce our speaker for today. Our speaker for today is Mr. Kenneth Anakoli. I think I met him for the first time 3 weeks ago in Vienna. He's a principal scientist at the Nuclear Power and Energy Agency in Kenya. He specialized in site selection and evaluation for nuclear installation, monitoring, equipment, and other energy installations, including back-end radioactive waste management, environmental impact assessment, and radiation protection. He has extensive experience in developing policies, strategies, and framework for various infrastructure issues in Kenya's nuclear power program. Mr. Anakoli has a Bachelor of Science in Geology and a Master of Science in Nuclear Science, all from the University of Nairobi. He has attended a number of professional training in environmental audit, senior management course, performance evaluation from Kenya School of Government, and ISO 9001 audit. He has also attended international trainings on nuclear knowledge management at the International Center for Theoretical Physics in Italy. Also, nuclear power plant engineering course at Texas A&M University in the United States, and interregional course on nuclear power plant management at Cape Coast International Nuclear Graduate School in South Korea. Mr. Anakole is also involved in stakeholder engagement for the nuclear power program, where he engages in promotion of nuclear technology in various applications. He has knowledge of programming tools such as C++ and Java. He is also a professional member of the Geological Society of Kenya, East African Society of Radiation Protection, and the Nuclear Society of Kenya. As part of the mandate of the Nuclear Energy Committee, we are supposed to create public awareness, and I saw that in Mr. Anokoli's profile. So please help me to welcome our guest and speaker for today's topic on nuclear power plant site selection, Mr. Kenneth Anakoli. Please, thank you for accepting our invitation, and you are welcome. Please, a round of applause. You can use the emoji.
Thank you, Engineer Soleil. Indeed, we met 3 weeks ago in Vienna, and I'm happy to see you again as I try to dissect this issue that is quite familiar to you because you're also an expert in this field. So I'm happy to share with you this platform. It's indeed an international platform that I want to appreciate Madam President and Madam Vice President, and of course yourself as the MC for allowing me to share my knowledge and my expertise with fellow engineers, scientists. And also, I must state here, I've also invited a number of social scientists because as you have been told, I am involved with stakeholder engagement. And I work with the principle that if you want to go far, you go, if you want to move fast, you go alone. But if you want to go far, you must go as a team. So social scientists are very key in this area of, or in this industry. And it's important that we all move together. Engineers are important, scientists are important, but also social scientists are also very important. So thank you so much. I don't know if you'll allow me to proceed and just go ahead and present.
To our participants, you can put in your comments in the chat box. When the speaker is done, we can address your questions. So you can put your questions in the chat box. Please, you can proceed to say.
Okay, thank you. So I would like to share my screen just shortly. And then you'll allow me to switch off my video because of, so that we have a good, I mean, we don't have feedback on the internet. So I believe everyone can see my presentation. Now, my name is Kenneth Anakoli, as you've heard. I don't want to repeat my profile, so I'll just move direct to my presentation. And as an introduction, we can't speak about nuclear power plant or nuclear installation siting without introducing briefly the nuclear power program. And I would like by stating that a nuclear power program is a structured national initiative to develop, implement, and regulate the use of nuclear energy for electricity generation and other peaceful purposes. So the vision of a nuclear power program is to ensure long-term energy security, support sustainable economic growth and industrial development, reduce greenhouse gas emissions, promote technological advancement and self-reliance, and environmental protection and conservation. Now, there's a reason why I put this as the last point, because a lot of people, because of perception, are still not aware that nuclear facilities are quite much involved in protecting the environment and preserving the environment. And probably through the entire presentation, we are going to dissect that, and even through the question and answer session. Now, in a nuclear power program, there are certain issues that must be canvassed as we progress. So there is milestone 1, milestone 2, and milestone 3. And so in milestone 1, we have a number of issues. Okay, in every milestone, each issue we have to demonstrate as a country, or you have to demonstrate as a country that you are aware and you are tackling these issues to a certain degree and to a certain extent. And I will just go very fast. I'll move very fast through these 19 infrastructure issues, where we have the national position, because nuclear power program is a political program. It relies a lot on political leadership. And so there has to be leadership from the national platform. We have the second issue, which is nuclear safety. You must be able to demonstrate as a nation that you are able, or you have the correct infrastructure to operate a nuclear power plant or a nuclear facility in a safe manner. In terms of management, is how the power program, the entire program is going to be managed, the institutions and the overlapping roles and the responsibilities of each institution, and how they can be used or utilized to manage the power program. Funding and financing, you must, of course, in any program has to be funded. Projects and programs have to be funded or financed. So how do you get the money or the capital? Because a power program such as a nuclear power program is heavy in terms of capital. So you must be able to demonstrate that you can be able to get this funding to fund the program. You must also demonstrate that
Kenneth,
you have the...
excuse me. Hello, Kenneth. Can you make the PDF a full screen?
Okay. Yeah, that's the farthest can go.
Okay, I think just below where the page numbers are, below there's a sign that shows like back. Then below it, there's something that like expanding the sheet. Yes, I think it should give it.
Okay. You know, this is a PDF, so it can't go beyond this, unless I zoom in.
So where, yes, you should see zoom to, I think the last option should give you something like zoom to fill the screen. Yes.
Are you okay now?
Yes, thank you.
All right. Okay. Thank you so much. So a legal framework, you have to demonstrate that the national laws are in tandem with those of a nuclear power program, so that the national laws can be able to support the program. In terms of safeguards, of course, this is also almost similar, but you have to demonstrate that you can be able to protect or to prevent the nuclear material from falling into wrong hands by signing. One of the ways of doing this is by signing, for example, international treaties. For example, the Nuclear Non-Proliferation Treaty. The regulatory framework, you must be able to have a national regulator, a nuclear regulator that can be able to regulate nuclear activities. Radiation protection, it must be robust within the country so that to protect the people, property, and the environment. Of course, for a nuclear power program, and specifically for a nuclear power plant, you must have a grid. And the purpose of the grid is to evacuate power from the nuclear power plant, and also to supply offsite power to the nuclear power plant. You must have the requisite or the critical mass of the human resource within the country to be able to operate or to undertake a nuclear power program. Stakeholder involvement is a key. It's very key because people must accept the program before you proceed. I have ticked or marked the site and supporting facilities because that is our main topic of the day. Of course, we have others, environmental protection. You have to protect the people, the property, and the environment from the harmful effects of ionizing the radiation. Emergency planning. So in the case of an unlikely event of a radiological or of a nuclear emergency that leads to radiological fallout, you must be able to put up mechanism or to set a mechanism to be able to protect the people, the property, and the environment. Of course, nuclear security. This is protecting the power plant or the nuclear facility from harmful intruders, or from from not allowing people to come in, bad people to come into the power plant too, or the nuclear facility. The nuclear fuel cycle basically is where it relates to the nuclear fuel from mining. Of course, the main nuclear fuel is uranium, although thorium is also coming up very quickly. So mining, milling, process, fabrication, mining, milling, enrichment, fabrication, and then when the fuel is at the reactor, moving from the reactor after irradiation, and how up to when it's going to be managed as a spent fuel. So we don't call it nuclear waste, we call it spent fuel because it can still be reprocessed. Radioactive waste management is
Hello, Kenneth.
Hello.
Hello, Kenneth.
okay. Someone unmuted me.
Oh, okay. Sorry.
I hope I'm back because it has just shown me on the screen.
Yes, you are back.
Okay. Thank you so much.
Kindly zoom.
So is my presentation still on?
Yes, but it's gone back to the default.
Okay,
screen.
let me
Screen mode. Okay. Thank you.
So where please help me. Where was I before I got muted?
So radioactive waste.
Radioactive waste management. So we have to country must be able to demonstrate that they can be able to handle, or they are planning to handle, the radioactive waste. And for industrial involvement, a nuclear power program involves literally a lot of industries. So we have to involve all the industries within the power program, and then procurement, because procurement, you have huge components that have to be procured. So we must have or demonstrate the capability for nuclear procurement. Now, let's go to the topic of the day. That was just in a nutshell. So this topic is of great interest to a lot of people because initially during the 50s and 70s when the 50s and 60s when the first nuclear power programs were being introduced for civilian uses, the issue of site selection was not very very important then because the issue of perception of nuclear power was not big. But right now, because of the perception, lack of understanding of thereof, uh, uh, the International Atomic Energy Agency has come up with mechanism or with the mechanism of site selection for nuclear installations. So this mechanism is to build confidence in the public so the public can understand that they are well protected. So when I speak about nuclear installation, I'm not just talking about the nuclear power plants, I'm also talking about the radioactive waste management facilities. I'm talking about other smaller facilities like the nuclear research reactor facilities that produce isotopes and that are used for research and training. So the site selection process is a process of identifying and evaluating appropriate sites for building nuclear facilities that ensure safety, sustainability, and compliance with national and international regulations. And the main purpose for site selection is to protect the public health and the environment. It's also for regulatory compliance so that it meets all legal and licensing requirements, operational efficiency, which ensures reliable infrastructure and resource availability, and then to gain public acceptance because this minimizes social resistance through responsible planning. So let me, in the second bullet about regulatory compliance, I need to put a disclaimer here. So site selection, there is the initial stages of site selection which are not regulated, but there are stages thereafter that will be regulated, and I'll be able to explain in this slide. So the general overview of the site selection and site evaluation is this. First, we have the site survey stage where we identify potential regions, potential sites, and candidate sites through screening and comparison. And then we have this site selection stage, which is evaluation and selection of final sites through the ranking of candidate sites. Now, these two components form what we call the siting process. Now, when we proceed from there, we go into the site evaluation process, which overlaps with the siting process. So in the site evaluation process, we proceed from site selection stage to site characterization stage, where we conduct confirmation of acceptability and complete site characterization, and then derivation of site-related design basis. So this is basically detailed site evaluation, and I'll tell you later on what this detailed site evaluation is. And then we go to pre-operational stage. That is the fourth stage, where the confirmatory work and monitoring work is undertaken. And then the final stage, which is the operational stage, where confirmatory and monitoring work evaluation as per periodic safety reviews. Now, for site selection, like any project, must be undertaken through a project management approach because it's a big project. It takes around 1 year to around between 1 to 3 years, right from site survey to site selection. So you must have a team, and this team must be organized through a project management approach. And the importance of this is to plan clearly, so that there's clear planning and direction, and then it's important for resource management, where you manage time, people, and equipment. Risk management also, project management assists a lot in risk management and also helps in accountability and seamless communication. And the components of the project management are, of course, the initiation, which provides the purpose and the scope, the planning, where you do the budgeting, the WBS is the work breakdown structure, resource allocation, and scheduling. And then the third component is execution, where you do or you conduct coordination and implementation. The fourth component is monitoring and evaluation. Of course, after you've undertaken an assignment, you have to monitor and evaluate, and then closure. Of course, you must organize your team in a, I would say, in an organized manner, where so that you're able to clarify roles and responsibilities, and facilitate efficiency and accountability, and to improve communication. So this is one way of organizing a team, where you have the team leader, who is basically the one in charge of the overall leader of the entire project. And then under the team leader, we have the quality management, a person who is in charge of quality management and technical review. Under the team leader also, we have the technical team, which is in charge of geohazards assessment, meteorology, hydrology and oceanography, environmental and social impact assessment, human-induced hazards, emergency planning, population, and land use. And this is just some of the technical components. These people, I mean, this is not wholesome. It's just some of them. And then we have the regulatory and licensing. So basically, you have someone in charge of looking or evaluating whether a certain activity is or requires regulation. And sometimes you might have one person from the regulator to just come and offer an observatory role, so that the regulator is not left behind in these activities. So you also have to have someone who is in charge of project control, also another one in charge of stakeholder communication, and also another in charge of administration. Now, in administration, you have procurement, logistics, legal, HR. Okay. Now, under administration, you don't really have to embed them within the team, but you can use the administrative arm of the organization, the parent organization, to assist this site selection team to conduct its activities in the to assist in the administration of the conduct of the site selection activities. Of course, this is just a snippet of a project planner. You must have a project planner. You must have something like a Gantt chart to be able to just to track your activities. Now, the other thing you must have, which is very important, is a quality assurance program, which is a systematic process to ensure that the project's deliverables and processes meet defined standards and stakeholder expectations. So quality assurance is different from quality control, because quality assurance is basically how the process is undertaken, just ensuring that the process is undertaken as required, as contrasted with the quality control, which is product forecast. So how do you conduct quality assurance? Of course, we have process audit, where you audit the processes. You have a checklist. Of course, you have peer reviews also, documentation, standard operation procedures, and you train the team.
Hi, how was your day? Did you enjoy riding the bike? Hi,
I'd like to request people to
riding the
unmute,
bike.
please. Engineer Sule, please assist me to mute.
I think he's muted now.
Oh, okay, thank you so much. So, and as we enter into the nitty-gritty of the site selection, we have to understand that it is an iterative process. What do I mean? This is a cyclic approach to building, refining, and improving a decision. So siting of nuclear facilities follows this approach that offers guarantee of a robust, ingenious, and sound decision. So how do you start? How do you do it? You begin with the regions of interest, and then you conduct regional analysis. So under the region, within the regional analysis, there is a decision you have to make as a team. So you use a regional criteria to reject areas, and this regional criteria will be able we will be able to converse in the later slides. And then you come up with potential sites. Then after you come up with potential sites, there is still a decision that you have to make when you conduct a screening test, where you reject some of the potential sites because they don't meet a certain criteria. And this you do after that, you conduct further analysis and get a reasonable number of candidate sites. And then if you do not have a good number of candidate sites, you will be forced to repeat the process with what we call a graded approach, where you go back to the criterias, and then you lessen the criteria a bit. The requirements become at least less stringent, so that you are able to get a good number of reasonable candidate sites. Once you get a reasonable number of candidate sites, you conduct what we call ranking using a ranking criteria and evaluate, compare. You evaluate, you compare, and contrast and rank all the candidate sites. After that, you come up with the preferred candidate sites and an alternative site. So basically, you're supposed to come up with two. Number one, the first and the second site should be good to host a nuclear power plant. But when you do a pairwise comparison, of course, you have a preferred site between the two, and then the other site becomes the alternate or the alternative site. So what are the criteria for siting? We have mainly two criteria: exclusionary criteria and discretionary criteria. So under the discretionary criteria is what we have the avoidance and the suitability criteria. These criteria are related to attributes that are grouped into thematic sets as follows. So we have those criteria that are grouped into as external natural hazards, and then external human-induced events, the criteria related to radiological impacts on the public and on the environment, emergency planning, and then considerations not directly related to nuclear safety. The last set is considered to have a major bearing on the effectiveness of the siting process. So let's go one by one on the exclusionary criteria. Now, this is not, this does not mean that the first one is the most important one. This is not according to hierarchy. These factors are taken as, they are ranked as same. So in terms of volcanism, lava flow, pyroclastic flow, ground deformation, and massive lahars are considered an exclusionary criteria. So what does that mean? That means that you exclude those areas from being considered as potential hosts for nuclear facilities. And what is the reason? The reason is because there exists no engineering solution. Or if the engineering solution exists, it's too expensive to make economic sense. I think that should be clear. Now, the other criteria is feasibility of implementation of an emergency plan. So if it is not feasible, you exclude. And for instance, I'll give Kenyan case because, of course, that's my country. And this is basically what we did. An international border, when a site is in proximity or near an international border, and you do not have a shared legal or regulatory framework, then you exclude that site because you cannot impose your laws on a country's on another country's laws if you do not share the same laws. Non-safety criteria include the no cooling water available, and I'll have a disclaimer here. This is purely for terrestrial water-cooled reactors. That is for nuclear power plants. Non-radiological environmental impacts, for instance, environmental protected areas. So you don't site a power plant in for example, a national park. And this is because those areas are gazetted for specific environmental protection. So in terms of an earthquake, if you have an earthquake that will lead into surface rupture, definitely that's a no-no. So you exclude. We also have geotechnical factors or geotechnical criteria. And under this, if the area has massive slope instability, you exclude. But if it's not massive, that's why I put a yellow star here, you may apply discretionary criteria, and you will see in another slide. If the area experiences or has the potential to experience massive liquefaction, you exclude. But if the liquefaction is not massive, or if potential for liquefaction is not massive, you may apply discretionary criteria. In terms of karst, because sometimes some of these oceans are or shorelines have karst scenery. Karst basically means the landscape is composed of limestone or calcitic rocks. If it's massive, such as to they can form caves, limestone caves, then you have to exclude these criteria. But if the karst or the holes, the dissolution features within the karst are pea-sized, then you consider using discretionary criteria. Now, after you've conducted a regional analysis, okay, this slide just shows how you conduct a regional analysis. So we have basically here, you start with the region of interest. Then you screen through and get between 15 to 20 candidates areas, which are potential sites. And then you screen them further to between 4 to 6 sites. Now they are called candidate sites. The reason why they are called candidate sites is because these sites progress to ranking. It's just like candidates in school, where you rank number 1, number 2, number 3. So from here, you proceed with alternative sites, that is between 3 to 5, and then proposed sites. Sometimes the alternative site can only be one. They can also be more than one, but they can be between 1 to 5, which is okay. And then you have one proposed site. And the regional analysis basically excludes unsuitable areas using the factors that I had mentioned earlier. You identify potential sites through the regional criteria, and is also assist in facilitating decision making. So the main criteria used in the regional analysis are geology, hydrology, seismic activity, population distribution, and existing infrastructure. I'll be able to explain this in coming slides. Now, like I said, for water-cooled reactors, maybe I should add, for a water-cooled terrestrial reactor, absence of a permanent water body is an exclusion criteria. The reason why I'm adding a lot of words, water-cooled terrestrial, is because there are other technologies that are coming that are not basically water-cooled. And these technologies that are coming are going to probably and potentially change the way the future sightings of nuclear facilities will be conducted. And so we are also waiting, the whole world is waiting. Potential areas therefore lie around existing permanent water bodies. And permanent does not mean, permanent here means that water body can or has the potential or can exist throughout the lifetime of the power plant or the nuclear facility. And then large urban centers are also excluded. The main reason for exclusion of large urban centers is because of the cost of the inhibitory costs of emergency planning. So, for instance, in Kenya, the large water bodies are basically three. So, in the north we have Lake Turkana, in the west we have Lake Victoria, and in the southeast we have the Indian Ocean. So, for a water-cooled terrestrial nuclear power plant or nuclear facility, presence of a permanent water source is an important factor. So, nuclear facility or nuclear power plants do not consume water, but they utilize water to generate steam and to cool the reactor components. So water, they don't really consume, they just use the water and they turn it back to the environment. We proceed with regional analysis where we go to protected areas. And like I say, these are exclusionary criteria. During siting of nuclear installations, it is recommended to exclude existing protected areas. However, during operation, the undisturbed exclusion zone of a nuclear facility encourages natural growth of fauna and flora. The spread of natural growth can attract wildlife, and the area can subsequently be gazetted as a protected zone alongside the existing nuclear facility. For instance, we have a very good example in Africa, Coburg Nuclear Power Plant, which exists alongside the Coburg. There's a national reserve or a national park around that facility. And this, the reason why I put this, the reason why I'm saying this is because in our stakeholder engagement, people believe, or because of the perception, people believe that a nuclear facility should be located very far away from people, very far away from the environment, simply because of the NIMBY, they're not in my backyard, but also not because of the perception that a nuclear facility is inherently harmful to the environment, which is not the case. So national parks, reserves, forests, including mangroves, wildlife corridors, archaeological sites, UNESCO zones are some of the protected areas. Now, when I say protected, I don't just mean protected, but I also mean officially gazetted by a country. Let's go to quakes, faults, and volcanoes. You do not want to put a power plant in an area that experiences earthquakes that lead to surface rupture. Fault lines are an exclusion criteria because fault lines can be capable, and fault lines are potentially hazardous to any civil structure, including a nuclear facility. Volcanogenic and seismogenic earthquakes must be characterized to see or to demonstrate that they do not, or they may not lead to surface rupture before you consider setting or locating a power plant or a nuclear facility in that area. So exclusion criteria is applied in this factor when there is no engineering solution, or if the engineering solution does not make economic sense. For example, in Kenya, we have the Great Rift Valley, which is a major active geological feature. Basically, it separates at 2 millimeters per year. So this is an active fault zone. So from a geological timescale, it's believed like in a few million years ago, Kenya is going to separate and form an ocean right there, because a few million years to come, I mean. So because separating 2 millimeters per year will lead to separation of the country into a different earth crust, plates. So exclusion criteria is recommended due to weak geotechnical characteristics. Along this Great Rift Valley, as you can see, it's a big thick line running from north to south, and there's a failed arm running towards the west, right into the Lake Victoria region, or Lake Victoria. So this entire area has weak geotechnical characteristics. Sometimes during rain, we experience subsidence and large subsidence. Volcanoseismogenic activity is quite rampant here. There is low probability but high propensity of a catastrophic natural hazard. So a number of earthquakes and volcanic activities do happen along this geological feature. And it's difficult to adequately characterize the region for a nuclear facility. It's very costly to characterize this area. So because that may not make economic sense, it's a candidate for exclusion. Another factor, and this is just one of them, but it's not an exclusion criteria, is electric grid. Proximity to an existing electric grid is a suitability criteria. Why? Because connecting the facility to the national grid is easier on a site that is closest to the national grid. And also, the cost of offsite power supply to the nuclear power plant or nuclear facility is greatly minimized. The cost of power evacuation from the facility is also minimized. So it's building a grid, an electric grid, to join, for example, a power plant. If you set up a power plant and the right at the northern border of Kenya and Somalia and the Indian Ocean, to the grid will be quite more costly than when you build it at the central region of the Kenyan coastline. That's basically what that statement says. This is not an exclusion criteria, but a discretionary criteria where supporting facilities, which include good road network, a railway network, seaports, and bridges, are key in determining the location of a nuclear facility. And this must come with a disclaimer that these facilities, the reason as to why these supporting facilities are important is to facilitate handling of over-dimension consignments, because some of the equipment of the nuclear facilities are quite big. They may not be able to be transported in normal or narrow roads or through roads that pass through large or constraining geographical features like hills, mountains, or bridges that may not sustain or do not have the bearing capacity or load bearing capacity of those consignments. These are examples of this Kenyan situation. So you use a lot of shapefiles and geographic information tools to conduct site survey and site selection. So you have shapefiles that you use to overlay them on the map, so that you're able to come up with excluded sites and sites that have the potential. So in the first frame, we have the entire Kenyan coast. Now in the second frame, we have part of the sites that shows, like if you see the northeastern side is already overlaid by a protected area and a large urban center. So you don't want to put a nuclear facility there. The northern part of the ocean also, or the coastlines also has an overlay of a large urban area or a protected area. So in between, there is an empty space where you can consider the area as a candidate site. So this is basically what you do in all the regions, so that you come up with the candidate sites. After you've come up with the candidate sites, okay, during selection of the candidate sites, there's also screening criteria that's undertaken. And these are pre-calculated figures, and the International Atomic Energy Agency provides it in a book called SSG 35, that's site selection for nuclear facility. And it provides figures that we can use to screen candidate sites or potential sites. So for example, distance from a capable fault. A capable fault is a fault that has the potential to move, to move either and cause either a strike slip fault or a normal fault movement. And this movement can cause surface rupture, which is not good for any civil infrastructure. The second criteria, distance from flight paths approaching an airport. So 4 kilometers is a pre-calculated figure. And this because after 9/11, it was determined that aircraft can be used as weapons. So nowadays, nuclear facilities, especially nuclear power plants, the large conventional nuclear power plants, are constructed in such a way that the containment structure can be able to handle an aircraft crash with the size of Boeing 747. Distance from airport with attributes of type 2 events, that's 7.5 kilometers away. So this is quite it's like a medium size to a large airport facility. And then we also have distance from small airports, 10 kilometers. I mean, the site should be 10 kilometers away, or the airport should be at least 10 kilometers away from the nuclear power plant site. The fifth screening criteria is distance from large airports. Yeah. So this should be, so number 3 is a medium size, number 5 is a large airport. The distance should not be less than 16 kilometers for airports of that characteristics. So a large airport should be at least 16 kilometers away because it handles larger aircrafts. Distance from military installations or airspace usage such as practice, bombing, and firing ranges. Now, a military facility can work both ways. Now, it's upon the team to consider it as either for security, for provision of security, or if that military facility handles or conducts or stores explosives, then it becomes a potential hazard. So it's up to the team to characterize the military facilities, to understand what kind of military facility it is, and then come up with the way or mechanism of siting a power plant near that place. But such facilities that handle bombing and firing ranges and explosives should not be closer than 30 kilometers away. Distance from military installations storing ammunition, that's 8 kilometers. And then distance from facilities for storing or handling flammable, toxic, corrosive, or explosive materials should be at least 5 kilometers away, simply because you do not want, for example, in case of an unlikely event of a nuclear accident, we don't say that they don't happen, but they're rare. The probability of them happening usually have a core damage frequency of around 10 to minus 8 or thereabout. So it's rare, but that does not mean they can never occur. But in case it occurs, such kind, number 8 is a human-induced hazard. In case it occurs, and then we have subsequent occurrence of such hazards, it becomes almost impossible to handle. So that's why these potentially human-induced hazards are cited or should be located at least or a minimum of 5 kilometers away. Now let's go to ranking of sites. After you have conducted the site survey, you have come up, you've done the regional analysis using the regional criteria, you've gone to potential areas, and then you've narrowed them down to, you've now come down to candidate sites. Now you want to rank them. Now, ranking is, the purpose of ranking is to conduct a more detailed study of a reduced list of candidate sites, assigning weights to various criteria to reflect their relative importance. This step results in a ranked list of preferred candidate sites, and you mainly use discretionary or suitability criteria. So what does this mean? If you've come to ranking and there's still an exclusionary criteria that is present, then that means you did not conduct proper exclusion criteria or proper regional analysis. So you have to ensure that the ranked lists do not possess any exclusionary criteria, or there is no exclusionary criteria that's going to affect the ranking process. And one criteria, potential criteria will be feasibility of implementing an emergency plan. You can have a very nice site, but it's near the border of a neighboring and near an international border, probably around maybe let's say around 5 kilometers away or 3 kilometers away. But it ticks all the boxes. But as long as it's around that place and you do not have any shared regulations or legal framework, then it's difficult. That's, I mean, it means you did not really conduct a good regional analysis using the exclusionary criteria. So let's run through the discretionary criteria very fast. In terms of volcanism, for volcanism, we have tetrafall. Remember, volcanism has different types. There are different types of volcanisms. Initially, we had, let me just go back to the slide. In this initial slide, in volcanism, we had lava flow, that is massive lava flow, pyroclastic flow, and ground deformation and lahars, massive lahars. Now here, we have tetrafall, volcanic gases, and lahars, which are not significantly hazardous as the previous previous types of volcanism. So in terms of tetrafall, you use discretionary criteria because sometimes a tetrafall can spread for a long distance, hundreds of kilometers away. You'll still be able to record tetrafall from a volcanic activity, but the significance or the level of hazard, the hazard levels for a tetrafall are much less than that for example, of pyroclastic or lava flow. Volcanic gases also are produced in in a volcanic occurrence, and so you apply discretionary criteria. And I had indicated earlier that discretionary criteria is where you have the avoidance and suitability. So this basically you want to avoid an area that has tetrafall. So if an area has tetrafall, if you have an area that has tetrafall and you have one site that does not have or experience tetrafall, you will prefer the one that does not experience tetrafall to the one that has tetrafall. But you just avoid. That does not mean the one that has a tetrafall is not a potential or a candidate site. That's where what we mean by discretionary. Volcanic gases is the same process. Lahars, I mean, the ones that are not massive, you also apply discretionary criteria and ranking criteria. So ranking basically, like I had indicated, a tetrafall, a site that experiences a tetrafall versus a site that does not experience a tetrafall, and then you can rank them. So if you use volcanism alone, then the one that does not experience a tetrafall ranks higher than the other one. In terms of flooding is a discretionary criteria and also a ranking criteria. So for a river, you want to avoid areas that experience flooding, but also you want to characterize the level of flooding. So if it is a dam break or a storm surge or a tsunami, and the levels, you just have to characterize them and see if the area can be suitable, can host a power plant. We also have non-safety criteria, for example, topography. Now, for instance, a coastline that is constantly shifting, or a coastline that is not stable, is not very suitable for, or if it is not very suitable for siting a nuclear power plant. But we have engineering measures that can be put in place to protect the shoreline from shifting. Topography, for instance, you have a site that is in between hills. So you'll be forced, for civil engineers, will be forced to cut and dump. And this this will have it will be a cost factor. It will bring in a cost factor, and therefore sometimes it's very costly to do excavation and dumping, so that you have a flat area or a flat platform for construction of the nuclear or civil structures of the nuclear facility. So this is basically a cost benefit factor. Transport availability, as I had indicated also, do we have roads that can handle over dimension consignment? If a site does not have accessibility by those kind of roads, then it doesn't rank better than, or it ranks lower than a site that has better road infrastructure or better rail. National grid, I had spoken about it. Socioeconomic impacts, for example, presence or absence of people to work in that area, growth of other urban facilities like markets, hospitals, schools, and others. Also, land use planning is also a discretionary criteria. So you have to look at the spatial plans for the local municipalities. So if they marry, then you are good. But if they don't marry, then you have to negotiate on how you're going to put up a power plant in that area.
Hello. Olabisi, please.
Okay, sorry. I thought I was muted.
No.
Okay. Okay, thank you. So not all earthquakes are bad for or are naturally severely hazardous. So if an earthquake, if the ground vibration is not significant, or if you characterize an earthquake to be very low on a Richter scale, for example, at level 4 or magnitude 4 or 3 at the Richter scale, that's not a factor that you can use to exclude, but you can use, or you can apply discretionary criteria. Geotechnical factors such as slope instability and subsidence, these are minor, not the major or massive slope instability that can cause liquefaction, but minor ones. You can use discretionary criteria. This one, massive liquefaction, is wrongly placed here. I think when I was writing this, I think the table was disoriented. So massive liquefaction is an exclusion criteria, but liquefaction that's not massive is not an exclusion criteria. It is a discretionary criteria. We also have extreme meteorological events.
Hello, Sam. Hello, Sam.
Hello, sir. I'm muting you and unmuting yourself again, please.
So we also have extreme meteorological events, sand and dust storms. Thank you. We have human-induced events such as aircraft crashes, explosions, gas releases, external fires, and electromagnetic induction. You can use discretionary criteria. And then nuclear security events such as terrorism activities, you apply discretionary criteria. After application of all these criteria, what next? So when you conduct ranking, definitely there's a methodology. And ranking, you use a multi-criteria ranking tool. For instance, there are quite a number, but most prevalent one is the analytical hierarchy process, the AHP, where you define the problem and goal, clearly articulate the decision to be made and the desired outcome. Then there is a structure the hierarchy, where you decompose the decision problem into a hierarchy with the overall goal at the top, followed by the criteria and sub-criteria, and finally the alternatives at the bottom. Then you conduct pairwise comparisons, where you evaluate the elements at each level by comparing them in pairs to assess their relative importance of preferences concerning an element above them in the hierarchy. Then you calculate the weights and consistency ratios, where you derive numerical values representing the relative importance of each element, assess the consistency of the judgments to ensure reliability. Then you aggregate the weights, where you combine the weights across the hierarchy to determine an overall score for each alternative, and then make the decision, where you select the alternative with the highest overall score as the most suitable option. Within the analytical hierarchy process, there's also another one. You can use a Delphi.
Please, I've asked the speaker to unmute, sir. Please, can you unmute yourself? I've muted all other persons.
Okay.
The speaker, please kindly
Hello.
unmute yourself, sir.
Kenneth, so the admin has muted everyone, so you can unmute and continue. Thank you.
So I can proceed. And please confirm if you can hear me.
Yes, we can hear
Yes,
you.
we can hear you.
All right, thank you. So within the multi-criteria ranking tool, that's the analytical hierarchy process, you can use the Delphi questionnaire, which is, although it's highly subjective, but it's dependent on expert opinion, where you have experts and you ask them, for example, on a scale of 0 to or 1 to 5, how important is this criteria or this factor to this site. So that's just a raw example of a Delphi questionnaire. But the main intention is to converge, to ensure or to bring a convergence of opinion within or amongst the experts. And the key features include anonymity, iteration, control feedback, and statistical aggregation. This is an example. It's just one of the ranking we did. It's just part of it, just snippets where you can see the first level. This is level 1, where you do what the main ranking factors are compared. I think a pairwise comparison is done in the first tier, and then the second tier in the number 2 ranking subfactors, and the third tier in the ranking of the sites. So you may come up with absolute figures or some fractions, but this because this was a tool that was created by one of our members, our team members, that came up with that. I mean, it came up with these fractions, or numbers or figures with decimal places. But sometimes the tools may come up with absolute figures like 1, 2, 3, or absolute numbers.
Hello, I hope you
Now,
can hear me.
yes, I can hear you.
Oh, yes, please. This is who? Maybe your name, kind. Sheila, are you able to?
Hello, Kenneth. You can unmute yourself and continue, please.
Hello, you can hear me?
Yes, we can hear you, but you have to maximize the screen.
Oh, okay. Sheila. Okay, let me find out.
Okay.
Miss,
I need someone to confirm that they can hear me so that I can proceed.
Yes, we can hear you perfectly.
Thank you so much. So now we were talking about site survey, but then the next step is site selection. That's the next stage. And this one I'll move very fast. Probably within the next 10 minutes we should be done. So in site selection stage, there's a number of, once you have selected a site, once you have ranked them and you have gotten the preferred site and the alternative site, now you have to go further and set up monitoring tools or monitoring equipment. For instance, a meteorological station or a seismological station. Usually those are usually the first monitoring equipment that are installed at or near the preferred and alternative sites. So you must, and the importance of this tool is to collect or to have a database to assist in having a database that will be used to characterize the site. So you must have a seismological database where you have available information on prehistorical, historical, and instrumentally recorded earthquakes in the region, and paleoseismological data, if available. They have to be collected and documented. I'll move very fast. You must also have a database relating to fault displacement. You must have a database related to volcanological database, database on geotechnical hazards, database on coastal flooding, database on river flooding, very important, and database on extreme and rare meteorological events, a database on human-induced events, and on population, land use, water use, and environmental impacts. Now, let me go very fast to a graded approach. During the nuclear renaissance, I mean, that means during this period, because there was a time when nuclear power plants the construction of nuclear power plant went really down. But right now, the nuclear industry is really coming back, becoming very active. So that's what we call the nuclear renaissance. There are certain technologies that are coming up, and one of them is the SMR, small and medium-sized reactors. So normally, the conventional reactors are the current ones around 1,000, produce around 1,000 megawatts and above. But of course, we have some that produce 700. Those are still called large conventional reactors. But now there are certain technologies, the small medium modular reactors that are coming up. They can produce as low as less than 100 megawatts, one module. They can be connected as batteries, not literally, but in series. I mean, they can be installed to increase the power output. So you have to apply a graded approach in siting of such installations, because you have to, these installations, because they're small, the risk is diminished. It's not the same as the large nuclear. The associated risks are usually lower than those of the large nuclear power plants. So you have to apply safety requirements in a manner that is commensurate with the potential hazards and associated risks. So this graded approach is applied. It's a risk-informed assessment where you evaluate site-specific hazards, for example, earthquakes and floods, based on the likelihood and potential impact, allowing for focused studies where risks are significant. You apply a performance-based criteria, setting safety goals that the SMR must achieve, rather than prescribing specific design features, enabling innovation while ensuring protection. Integration with the design, where you consider how site characteristics interact with reactor design to ensure that safety functions are maintained under all credible scenarios. And main focus is on emergency planning, where you focus on the extent of the impact. Now, there's a certain technology that will be a game changer that the Russians have already constructed. And this is not to advertise for them, but it's because it's the only technology that is currently available. It's no longer a first of a kind. It is actually currently operating. I think it was deployed in Pevek, Russia, I think in the year 2020 or thereabout. It's called an academic Lomonosov, which is the world's first operational floating nuclear power plant, providing energy to remote Arctic regions. It can be a game changer and a solution for the capital costs, NIMBY, and remote areas that terrestrial NPPs cannot be hosted. So NIMBY means not in my backyard. The siting considerations must be reevaluated, where the main considerations are proximity to demand centers, geopolitical stability, and infrastructure availability. So you see now we are shifting from the technical earth or geological, seismological, to geopolitical issues with floating reactors. So we have advantages. They come with a number of advantages, where number one is rapid deployment. Factory fabrication and shipyard assembly enable quicker construction and deployment compared to traditional plants. Mobility, floating SMRs can be relocated to meet changing energy demands or to serve remote areas lacking infrastructure. Reduce land use. By operating so offshore, these reactors minimize the need for land acquisition and can serve regions with limited available land. Enhanced cooling. Surrounding water bodies provide an abundant heat sink, facilitating efficient reactor cooling. And it's an nth of a kind, no longer an first of a kind, as it is currently deployed in PVEC. So, for example, in Kenyan scenario, where we excluded the Lake Turkana region because of the Great Rift Valley. Now you see those hazards may not work. I mean, they may work differently when a nuclear power plant is stationed on the lake itself. So those are things that we have to consider. So Lake Turkana, the northern part of the lake that's at the northern part of Kenya, may be a potential site for hosting a floating SMR because of those graded risks. Now, I would like to end with a call to set pace for other energy projects. Nuclear facilities currently are if not the most are highly regulated. Nuclear power plants are highly regulated. Siting, site selection, site characterization. I mean, from site characterization onwards, it's a highly regulated activity. And so the reason why they're highly regulated is specifically, and this is my opinion, I could be wrong, but it's specifically because of the perception. One of the major reasons is because of the perception. Otherwise, nuclear power plants or nuclear facilities usually live very well with the human environment and property. So why am I saying this? Because it's not the same. Citing a nuclear power plant or nuclear facility is not the same as, for example, citing a hydroelectric dam, geothermal power, wind, and solar, or any other energy source like coal and other thermal like diesel. But these are a bit different. And even electric grid, for example, substations. These are also, I think, in my opinion, we need to apply a sort of, even if it's a graded approach, a sort of approach where, or a methodology that will be able to assist in siting of these facilities. And why? The reason is because this methodology applies a comprehensive risk assessment. Applying nuclear level assessments could prevent disasters and reduce long-term liabilities. Also for environmental protection, which ensures protection of ecosystems, biodiversity, and water sources from pollution, land degradation, or habitat loss. It's also good for public and stakeholder engagement, where it promotes transparency and social license to operate, helping avoid opposition and delays seen in projects with poor community involvement. Long-term planning and land use optimization. When you apply these criteria in a graded approach, it can be used for better land use policies and project longevity, avoiding conflicts with future land development or conservation goals. It's also good for emergency preparedness and safety. When applied well, it can be good to offer resilience to climate change, which making this a standard across all energy projects ensures climate resilience infrastructure, particularly for vulnerable coastal winds or solar farms. A cumulative impact consideration prevents over-concentration of projects in environmentally sensitive or overburdened areas, improving environmental justice, and standardization and accountability. Because here, this is very key. There is no other energy project or no other project that is highly, I would say, overregulated as nuclear power project. And this one really increases the cost of construction of a nuclear power or nuclear facility, because it is, I mean, if you standardize this process, then the competitiveness of all of nuclear facilities is enhanced. So in conclusion, siting of nuclear installations follows a methodological approach guided by the IAEA, and the purpose of this approach is to diminish risks associated with natural and man-made hazards that may have adverse effects on the people, property, and environment. Small modular reactors or small medium-sized reactors and floating reactors can bridge the gap where it is difficult to have terrestrial and or conventional nuclear installations. And all energy projects that may affect the environment should subscribe to this approach to minimize risks caused by their failure due to natural phenomena. And that, ladies and gentlemen, I would like to end my presentation with the question and answers. Thank you so much.
Thank you, Kenneth. That was an insightful presentation. We thank you for sharing your knowledge and experience. I think we'll take questions now. Before I open the floor for questions, I think some people have already asked questions in the chat box. So we'll take about 4 of them, give you the opportunity to respond, then we'll take the next ones. So the first question from David. David is saying, in France, out of the 19 sites housing the 56 operating nuclear power plant, only 4 are by the Atlantic Ocean and the North Sea. The national leadership decides, and the scientists, engineers, plus regulators have to follow. In both South Korea and Japan, who sit on the ring of fire, so it says seismic active exceeds our Great Rift River before Fukushima. Japan was operating 52 MPPs, while South Korea is operating 24 and building more. Discuss the action you will take if the national leadership say followed. Okay, so it's trying to say France has a leadership that can decide on where to site a nuclear power plant, and engineers and scientists are supposed to comply. I think that's what he's getting at. So if the same is applied, what if the national leadership say follow the France example? What are you showing is, I think it's not too clear. Question is not too clear. I'm getting the picture as if so siting follows a due process, assuming a country leadership decide to select a site for the country, for the either the engineers or scientists to follow. What's your take on that? I think I've summarized it in that way. It's not too clear. So that's from David. The second question from Humphrey is asking, why is Lake Victoria categorized under no cooling water, and yet it's a freshwater lake? I understand Lake